Hey everyone, let's solve today's LeetCode challenge. Determine if a cell is reachable at a given time. At the first moment, I thought it is a very straightforward BFS solution, but later on, after seeing the constraint and seeing the condition that we'll just have to reach the destination at exactly t seconds later. So I tried with a couple of example and found out that it's a very straightforward mathematical problem. So let's start with this approach. Here we are given 2 points x1 y1 and x2 y2, and we have to reach from starting position to ending position in t time. Okay, with an example, let's say our starting point is 0 0 and ending point is 4 and 2. So, and we are allowed to move from any point to a direction, these four direction, as well as in the diagonal direction, and traveling in each direction will take 1 unit of time. So from this point, either we can move up or right or maybe diagonally towards our destination. So in this way, we are given with a starting point and ending point. We can just directly try to find the distance between them. So if we are able to find the minimum distance or the distance between them, we will be able to figure out the time, like how much time it will take from source to destination. And also the diagonal movement is also taking 1 unit of time, so we can move diagonal as much as we can and then in the right direction. Or what will be the distance? 1 2 3 4. Even if it is a square, then we can directly figure out that it is from 0 to 0 to 2 and 2, the 2 will be the distance. So in this case, the distance will be 4, the maximum of this x2 and y2, because our starting point is 0. Let's try with another example. Let's say we have 2 4 as a starting point and 7 7 as our destination point. So we have to reach from start to end, and we have to calculate the distance between them. So from 2 to 4, 1 unit, 1 unit, 1 unit, 3 units are covered, and then 2 units in this direction. 3 in the diagonal is also going to take 1 unit of time. So 1 1 1 and 2 remaining units 5. So formula can be derive is 7 minus 2 is 5, 7 minus 4 is 3. So maximum of this will be our distance between these two nodes. If you are not able to catch it, just try with an example where the reference point is 0 0. From 0 0 to 4 2, we can move in 4 steps, 2 diagonal steps and 2 straight steps, which will always come out to the maximum of these two if the starting point is 0 0. And in this case, if you are confused among these two values, just make the first value as 0 0 0 and 0 after reducing 2 and from 4 from each value. From here as well, if we reduce 2 from 7, it would be 5 and 3. Okay, and the maximum between these two is 5. So 5 will be our distance between these 2 points. And now, apart from these 2 points, we are also given time t, that we have to reach in time t. Whether the distance is more than that or maybe less than that, we are bound to use t unit of time. So in our first case, let's say we have to reach from 0 to this 4 2, and our distance, what was our distance? The distance was 4 unit, and we are given 1 unit of time. So in 1 unit of time, it can either reach these 3 position if it is going in this direction. So it is impossible to reach to destination if our time given to us is less than the distance. If it was equal to the distance, then was it possible? Yeah, it was possible if t was 4 and d was 4, and even if the t is 5, In that case, instead of in that case we can utilize one more step anywhere, because it is an infinite grid. Okay, so D should be less than and equal to time. Okay, let's move further. So we are able to calculate the distance between 2 points, the absolute value of the difference between x and difference between y, and the maximum of both will be the distance. So once we have the distance, we will just straight away check with the given t. So if the distance is less than equal to t, we will just return true, because in that case we can reach to the destination at strictly t time. And if the distance is greater than the t, if the distance is greater than t, in this case we don't have enough time to reach to the destination. Okay, now let's move further. Also, this is the case like which I encountered while submitting the problem. Let's try to understand that as well. If the starting point is 0 0 and ending point is 0 0, in that case what will happen? Let's say our starting is 0 and ending is 0, and we will check it for different time values. If the time is 0 and we have to reach to 0 0, we are already at the destination, so yeah, we can reach that. If the time is 1, we have to spend 1 unit of time and reach to the destination. We are starting from here, we can go in 8 direction, but after taking one step we don't have enough time to return back to the original point. So if t is 1, we cannot move coming back to the source position. If t is given as 2, in that case we can move in one direction and return back to the starting value. Yeah, 2 we can do that. 3 as well, move right and then from right to up and then to this diagonally source position. Yeah, 3, and so on. For all the values we can reach to the source position. So it is a special case. Let's handle that separately. So what is our solution so far? Firstly, we will calculate the distance between these 2 points, and then if the distance is less than equal to t, in that case we can we have the enough time to reach to the destination value. And this is our special case, when the source and the destination is the same position. In that case if the time is 1 and source and destination are the same position, in that case we don't have enough time to make a circle, or maybe spend 1 unit of time and after that time being on the starting position. Okay, so we will handle that separately. Yeah, I think that's the whole in the problem statement. Let's write the code for that. Firstly, we will find the distance and then check with given t. How do we find the distance? Int distance equal to math dot maximum value of math dot absolute value for fx minus sx, and math dot abs for fy minus sy. Okay, so absolute value between the distance of x and the difference of y, the maximum value will be our distance. And now we can check that with t. If the distance is greater than equal to t, in that if the distance is, let's say if the distance is equal to t, yeah, we will have to return true. If the distance is greater than t, in that case it would be false. So if the distance is less than and equal to t, we can just directly return true, else we will return false. Apart from that, we also had to check one condition. if the distance is equal to 0 and the time given to us is 1, in that case also we won't be able to perform this action. Distance is 0 and time is 1, that return false. If the distance is less, if we have enough time, we don't have enough time, because extra time we can waste moving around. Okay, let's try to submit this problem. I'm running it. Sample test cases are passed. Just submitting the solution. Okay, got submitted. Thank you.